Thank you very much for the introduction, and thank you for making the session this morning. It's quite early, and today we are going to talk about augmented reality and things that probably come to our mind first when we're thinking about integrating that new technology to an everyday life, and the simulator sickness. So it's all started, as you may know, from virtual reality and the display that Ivan Sutherland created in 1968. And people were thinking whether it's safe to use this device, whether this technology actually helps us to do things better or it harms our health and it's difficult to use it in our everyday life. And following this evolution from displays that have been created in the mid of the last century to something that was recently released by Microsoft, the Microsoft HoloLens glasses, we can ask ourselves, but is it safe to use augmented reality? Is it okay to integrate this device to everyday settings? And we conducted a research experiment within 3 different test beds to actually understand what does it mean and is it safe to use this device. So we work on the Wicked project, which has 3 industry partners. The first industry partner is basically aviation company, Lufttransport, based in Norway, in Tromsø, and it's a company producing air ambulances, and they need to perform a procedure, like a maintenance procedure for everyday life, and make sure that the plane is ready to fly. The second company is EBIT. It's Italian company producing ultrasound machines, and that's our medical partner. And the third company is Altec. It's part of the European Space Agency. It's a company based in Turin, Italy, and it's our space partner. And basically we started to think, how can we actually integrate 3 different industries with 3 different use cases, and probably representative enough to cover different tasks, and what are the tools that we can use to test that. So we created 2 applications for Microsoft HoloLens, namely Recorder and Player, 2 applications that allowed people to record an experience. If you think about the training, how you need to train people in these 3 domains, medical, aviation, space, you probably think about expert knowledge and how can we transfer that using augmented reality. So Recorder is an application for Microsoft HoloLens that basically records the whole expert experience, allowing them to create different types of annotations. I will show you the example a bit later. And the Player application is basically a tool that helps students or novices or new employees in the factory to wear that experience using Microsoft HoloLens and basically replay that pressing the play button and follow all the instructions to complete the training. This is an example of the Recorder application. So this is the tool that allow you to open some sort of a menu, the graphical menu, from which you can access different types of annotations, photo annotations, text annotations, video annotations. You can record audio. And one important feature of this application, that attention of the expert is coupled on the virtual world rather than the physical environment. And the next example of the Player is the tool where you have a sequence of the steps and you follow them, and in this case attention is predominantly focused on the real world because you perform the task in the real environment. Here you can see the example of the aviation use case where the person is opening the menu and creating an instructions, so you can access that information in different ways. Or on the right-hand side, you can see an example of combined recording in some sort of a ghost track of an expert where he is standing in the room and how he moves, so the student can follow the position. And in this case, in the aviation case, it's really important because there is a particular way how a student needs to perform this procedure around the cockpit. Because it's quite a big open space, and for augmented reality annotations, it's important to. We decided that it's important to have this type of instructions. For the medical case, you can clearly see the setup is absolutely different because we don't have a huge volume with the plane inside. It's rather something limited. It's an ultrasound machine. And here you can see how an expert, a doctor in the bottom left corner is basically creating annotations using different pointers and highlighters of how he can basically guide the attention of an expert. And all the pointers are saved within augmented reality using world anchors, so it can easily be represented in a different setups as well. This is an example of, for example, a person is trying to create an audio annotation. So you can drag and drop, and you can record it. You can stop recording, replay it. It was done a year ago, and I can understand that it's a bit too basic in terms of visuals and graphics. Because clearly today I wouldn't use the text menu in my life in augmented reality, because we're going to have a next iteration of the trials in a few months with updated interface and setup. And on the left-hand side, you can see a student following the instructions of augmented reality on the display and performing the carotid artery examination. With the space case, it's also a different setup where an Austrian trainer needed to attach a storage rack on a special setup, and it was done using this player application in this example, where you can see different pointers and video instructions of how you need to perform a procedure. And after we done this experiment with, we had 142 subjects at the beginning, and then we dropped 10 of them, as you can see, because we did pre-SSQ tests and post-SSQ tests, excluding 10 participants, because before the trial they shown that they had some headaches or different symptoms. And in total we evaluated SSQ score on 132 participants on the healthy subjects. And for this experiment, we used simulator sickness score. It's a method presented by Kennedy and Lane in 1993. And it basically evaluates simulator sickness based on 3 aspects, such as disorientation, oculomotor effects, everything connected with our eyes, and nausea. And as a result, after evaluation, we found that the 24% of participants, they experienced eye strain, and across all the test beds, this was the symptom contributed to the simulator sickness the most, because probably there are many different ways of how you can interpret these results. You can read more in the discussion of the paper, but we can clearly see that eye strain is connected to oculomotor disturbance, is the column named with O. And eye strain might be because it's the main, some sort of a interaction with the world in this case. But still, as you can see, it's quite negligible, and there is no some sort of a simulator sickness caused. And it's followed by the headache and difficulty focusing, but it's also grouped under the oculomotor symptoms, meaning that the headache and difficulty focusing were caused by the eye strain, potentially. If we think about different applications such as player and recorder, and since there were the attention was coupled within 2 different worlds, because with player application, when you replay the sequence, your attention is focused on the physical world because you need to perform a task, you need to hold the probe, you need to walk inside the cockpit in the plane, or you need to walk around the plane, and the setup where students were using player was a bit different. Whereas with recorder application, where you're creating a sequence of knowledge, your attention is focused mainly on virtual world. And you can see from the SSQ scores that among the symptoms groups, the recorder application basically had more effects because the annotation was mainly coupled within the digital world, and the person just clearly to say that some sort of lost this connection with the physical orientation. The proprioception was a bit breaking in this case. And if you look about symptom scores for 3 different test beds, such as aviation, medical, and space, we can see that within the spaced test bed, we had more simulator scores connected, because the setup was absolutely different, and I will explain that in the next slides, because within the space case, we had some sort of a platform, and the factors that had been within the environment, they influenced the final result. If you think about the aviation case and what exactly has happened there, we have a plane, we have a big hangar. Within this hangar, it's quite cold, and the person inside this place is some sort of walking inside the cockpit and then going inside and expecting the plane, performing different body positions and body movement, looking at different locations. Within the medical use case, a person is sitting, in this case, but we've seen different people doing this procedure standing, because for some of them it was more comfortable to hold the probe standing. Probably that was more natural for some of the participants. But usually medical use case is when you stand and sit, mainly sitting. And the space case, you can see that SSQ scores and their distribution are much bigger, because the person is experiencing this setup with the platform. So this lady, she's an astronaut trainer, and she's basically training future astronaut trainers to help them communicate with ISS module. And in order to complete this procedure of installation of the storage rack, the person needs to step on the platform and at some point go back and look at this platform and the setup as a whole, meaning that the movement included stepping in, stepping out, and looking around for this guidance instructions. Also, it was in late May, and in Italy, in North Italy, it was really, really cold. Some participants, they spent hours waiting to complete the training, to complete the procedure, participants of the experiments. And that's why the different atmosphere, the different factors, they contributed to the simulator sickness differently. But as a result, in total, there is no simulator sickness, only negligible effects that we found for the eye strain. And that could be interpreted differently, as I mentioned before. For example, if we connect that with the form factor of the device, of the display, some people, there is no one way how you can fit this device into your head, because we all are different, and it's quite tricky to say to everyone, please do like this, because we're all different. And that's why the form factor could affect the headache, and the headache could affect the eye strain as well. So we think that the device and technology is absolutely safe to use. There is one limitation or a study that I want to highlight. I don't want to say that augmented reality doesn't have simulator sickness, because we tested that only with Microsoft HoloLens. And since this is, as I think, this is the one device that is untethered and possible to use without any connections to the computers, it has quite wide field of view. But I can't say for different augmented reality glasses that there is no simulator sickness with them, because if you think about the current field of view, which is quite limited, we need to accept that. And considering that fact, all the annotations, they are positioned within our natural field of view, so you don't use your peripheral vision, meaning that you won't experience the same effects with different devices having wider field of view, and where information is positioned, all the augmentations, their positions on the side. Meaning that at this case, I'm happy that I made this highlighting of this limitation. And for the space trial, aviation trial, and medical trial, we think that these three test beds, they covered enough potential and possible activities that a person could do during probably an everyday training. And since we were testing this application with these knowledge-intensive environments where you perform a training or learning, we think that this study covered all of the potential and possible actions, and I truly like the space one because we get a feedback not only about the SSQ scores but also about technology acceptance, user interface satisfaction, and other different questionnaires that we run together with the simulator sickness. And we can clearly say that people are happy to use this technology in the future. They like the potentials, disregarding the current limitations, because they see the potential of how this can be integrated within everyday life. And this is the end of my presentation. Thank you very much for your attention.
We do have time for some questions. If you want to ask a question, come up to the mic, state your name and affiliation.
Hello, my name is Kenny from Hanyang University of Korea. So this is such a great presentation. And I have a quick question on your a basic hypothesis. So generally, augmented reality may have a smaller simulated sequence than other methods like virtual reality or other application, because we have some real components in here. So you have three different kind of application, but I believe you may have different percentage of the virtual object in according to the application. So maybe do you have an analysis according to how about the percentage of the virtual and real object too, and that can be effect to the a simulated sequence or other kind of some sort of a problem of your application of something like that.
Okay, thank you for your question. So it's like talking about the amount of augmentation that the scenario that they had. So the procedure they consists from 10 steps. So each expert required to create a sequence of 10 steps for all three cases, the different scenarios. And since they were allowed to use the same medium for creating that information, the same type of text, the same type of audio, video, or 3D models, the sizes of 3D models were also the same. And in this case, we think that they received an equal amount of augmentation in this case, but the difference is how they were positioned in the environment. Within the space case, they were positioned not equally in a different size, especially with the aviation case, where some of them were inside and some of them were outside the plane. And I can clearly say that with the medical one, it's probably it's not user-centered design in this case, it's probably object-centered design, where we have points of interest, a patient lying on a bed and the ultrasound machine, and person is moving between two targets. But I think that they received an equal amount of augmentation. Thank you.
Hi, my name is Danilo. I'm from UC San Diego. I want to know if you have any data on the subjects themselves, like their age, if the age range changed between experiments.
In
like
an expert. Yes, we collated the data about the age. It's in the paper. I forgot to mention one thing, that one of the criteria for the participants was that they had no experience with augmented reality. So that was the main, the same criteria for all the participants. But experts, they usually they are in the third age group, and the distribution with the age is different between experts and students.
Like for the subjects and the space application, the ones that felt nausea, were they older or younger than the participants in the other settings?
Participants, students, they are at
the
same age. Yes, there are master students in the universities within the cities that we were testing that in.
Okay, thanks.
Thank you.
Awesome. Let's thank Alla again.